Hello, this is Ishraq, and in this video, I'll discuss about my AWS Deep Racer Homework 1. So here are the parameters that I used for the training. I used a gradient descent batch size of 32. So the purpose of reducing the batch size was to reduce the scope of the track that was being evaluated or being of concern for the training. And then the entropy, discount factor, loss type, they were at the default. So I chose the loss type as Huber because this loss type, according to what I've studied, incorporates the best properties of both the mean squared error and mean absolute error in the sense that it is more robust in detecting outliers. And then I increased the learning rate to 0.001 and increased the number of experience episodes between the policy updates to 25 from 20 because I wanted to include more experience for all of the individual updates. And then the number of epochs was the maximum value set at 10. So I used the reInvent 2018 white track for both training and evaluation. My strategy was to apply a progressive and aggressive approach for the learning. So it is reflected in the way the reward function is designed because it aggressively rewards or penalizes the agent. So the concept of introducing a penalty kind of like increases the aggressiveness of the model. And then eventually the reward or penalty is scaled by how much the agent has progressed on the track. And then this is the specific reward function where we have the scaling factor along with a hyperbolic tangent function based on the difference of the track width and the distance from center. So the idea was to keep the agent within 80% of the track and then scale that value, scale the difference between -1 to 1. And then we scale this hyperbolic tangent value with the progress on the track. I use the proximal policy optimization learning algorithm for the reinforcement learning, and this is the results that I've got. So the results don't look very bright, but there are some interesting aspects of the whole training. Here we can see that the reward function or the reward value is directly proportional to the percentage of the track completed. And this is so because I introduced the progress parameter and the scaling based on progress that exaggerates the reward function based on the progress on the track, which I believe is helpful in this case. However, the average percentage of the track that was completed was around 9%, and most of the time the agent went off track, unfortunately. The time it took to complete each of the trials was around 2 seconds or 2.8 so seconds. Now, I believe the aggressive training policy is to blame for the negative results because it sort of introduced an opposite effect where instead of doing the system good, it does bad on the system. And then, like we saw before, the progressive policy helped because the reward was being scaled based on the amount of track or the percentage of track that the agent had completed. Now, eventually, I plan to reduce the aggressiveness of the model by changing the penalty and the reward policy. And then I'd want to create a rather smooth effect by reducing the acceleration to see how things go and by utilizing the steering angle of the agent. Thank you.